What the hell is that?
Oh.
I'm sorry.
Hello. Today we're going to be working on system of equations, but application problems where we left off the last time. We had already discussed how to solve a system of equations by using substitution. Then we used elimination. And then we saw some matrix stuff, just sort of picking up where we left off the last time. We looked at Cramer's rule and determinants. I said at the time that my preferred method for solving systems of equations is elimination. And that's going to be what I use today when I'm solving these word problems. I always say I prefer elimination and substitution combined. Well, yeah. Technically, we don't use strict elimination. You eliminate to solve for one variable, and then to solve for the second variable, you substitute. Yeah, that's right. Now, if you're using elimination, you need to remember you need to have the like variables lined up. An x column, y column, equal, constant. Like here, x's, y's equal constant. So what we're going to need to do on these word problems is identify variables. We're going to have x's and y's. You're going to need to write out what each one of these variables represents. Also, generally speaking, if you're looking for a unique solution, the number of variables must be equal to the number of unique equations. So if you have two unknowns, if you have two variables, you should expect the word problem to give you enough information for you to figure out two unique equations. So, two variables, you need two equations. Then you'll get a solution like that, 2, 3. A unique solution, one and only one solution, not infinitely many. Let's read through that. That's a final exam schedule. Here we are. Picking up for the last call. Number 15. A basketball player scored 20 times during one game. He scored a total of 29 points. 2 for each 2-point shot. That makes sense. He gets 2 points for each 2-point shot and 1 for each free throw. How many 2-point shots did this player make? How many free throws? So what are the two unknowns? If you look at those questions, the last couple of questions, that pretty much tells you what the unknowns are. How many 2-point shots did he make? How many free throws? Let's switch. That's going to be our unknowns. We want to know how many 2-point shots. So I'll let x be the number of 2-point shots. And y is the number of free throws. That's what it's asking you to find, and you can sort of tell that from the questions at the end. It asks, and keep rereading the question. Point to this. Okay, how many 2-point shots did he make? How many free throws? Okay, that's going to be the thing you're trying to figure out. I like to try to summarize this information in a table. I don't know if Tony uses tables or not, but I like to try to summarize this information with a table. And so I would write out 2-point shots and free throws in a table. And then you normally put the x and y over here. Let me show you what I like to do. Okay. We're looking at 2-point shots, 2-point shots, and free throws. Any basketball players out here? Yes? So, am I correct that free throws are worth, or they correct, I should say, free throws are worth 1 point and 2-point shots are worth 2 points, okay? So we said we're going to let x be the number of 2-point shots and y is the number of free throws. So I'm going to say this is my quantity. Well, you can name it however you want to label that column. I'll label it as the quantity. It's the number of 2-point shots being made, the number of free throws. And there's something else we know. We know how many points per shot we're going to get with each of these throws. Here's the points per shot. Points per shot. We know that every 2-point shot is worth 2 points. Every free throw is worth 1 point. And notice how many times we keep going back and reading the problem. We've got to keep reading the problem. This is referred to as synthesis. We're just trying to take in all the information they gave us. Now, keeping in mind, we're going to get 2 equations. That means there should be some sort of totals. And I think I see some totals right off in the problem.
Where do the 20 and 29s go?
Those are totals, aren't they? A basketball player scored 20 times. Switch back. He scored X 2-point shots, Y free throws. If you add X and Y together, that's the total 20. The number of 2-point shots added to the number of free throws should give us 20. He scored 20 times. Let's look back over there. What's that second sentence? How does it start? He scored a total of 29 points.
In those 20 shots.
So within those 20 shots, he scored a total of 29 points. So if we total up all the points that he scored, that should be 29. One equation falls out very quickly. Should be writing 2 equations with x's and y's equal a number. If you take the number of 2-point shots he scored plus the number of free throws, that should give us what? 20. He scored a total of 20 times. How many points did he get from these X 2-point shots? Just pretend for a moment. Suppose he scored 5 2-point shots. Suppose he scored 5 2-point shots. How many points did he get for those 5? 10. It's the point per shot times the number of shots. So you take 2 times X. Those are all the points that he scored from the 2-point shots. 2X, that's the number of points he got from all of those 2-point shots. How many points did he get from the free throws? 1 times, how many free throws did he make? Y, so 1 times Y. That's just Y, which equals 29. Any questions on our logic there? Now, the good thing is pretty much every one of these word problems sets up with that table that Tim just did. Identify the unknowns, point to that. Identify the unknowns. Then you'll have a X and Y column. You'll have some additional information. They'll have to give you something in terms of totals also. You'll have these problems have 2 variables. That means you want 2 unique equations. That's what we have right here. This doesn't look bad at all.
No, do you solve?
Yeah, now we got to solve. What do y'all think? We could use Kramer's rule, but I think that's like taking a chainsaw to cut butter. And I don't think we need something as advanced as Kramer's rule. Why don't we just substitution or elimination? I think this is tailor-made for elimination. What letter do you think I'm going to try to eliminate? X or Y? Y? Well, there's a smart Y to make negative, and there's one that's not so smart. Okay, good. Just multiply 3 by -1. So
Wait, why are we doing this?
remember, with elimination, you need the same coefficient but opposite signs. We have the same coefficient on the y's, 1 and 1. But we need one to be a positive 1 and one to be a negative 1. So multiply through by a negative 1. So this top equation, realize you're distributing that negative 1 all the way across. So that top equation becomes a negative 1x minus y is equal to negative 20. Do you remember doing that, adding it together, eliminating one of the variables? And the second equation, we're just going to leave it as it is. 2x plus y is equal to 29. Now let's add them together. Okay, so negative 1x plus 2x gives us just a plain x. And that negative 1y plus y, what's going to happen there? Okay, so you eliminated it. Equals negative 20 plus 29. What did you say, Mary May? 9. So that means this person scored 9 2-point shots. You can substitute into either one of these, but use the one that has the smallest numbers. I think this one right here, x plus y equals 20. You know that x is equal to 9. Plugging into x plus y equals 20, we get 9 plus y equals 20. Subtract 9, I agree. So, yes, to get y equals 11.
Remind me what rule that was that we used, please?
We're using elimination.
Elimination.
We used elimination, and then we substituted to get the second variable. Once you know that he scored 9 2-point shots, you could have just thought, okay, he scored 20 times. If there were 9 2-point shots, there had to be 11 free throws. Okay. Any questions on our logic there? But my advice to you, try to summarize the information in a table and recognize that you're going to be, where are the totals? Which numbers are the totals? As you read the problem, and notice how we were going back and forth, rereading the problem, each time picking out little pieces of information. Okay. How many 2-point shots? Which one was it? 9. Okay, and how many free throws? 11.
Can we go back to the written?
Okay, go back to the
Just for a
written.
second.
Yes.
Now, when we do the next problem, it's not going to involve basketball, but it sets up amazingly like that. And I like Tim's table better. When we do the next one, we won't write this stuff here. Okay, I like the way my brother sets up those tables better than those.
Okay,
It's all that linear programming from Math 1324. That's when I started using those tables.
Okay. Are we
Okay.
ready for another one?
Yeah. Number 16. A woman bought some. Let's see. A woman bought some large frames for $14 each and some small frames for $7 each at a closeout sale. If she bought 17 frames for $161, find how many of each type she bought. Now, I'm always mystified by these frames. Does she mean picture frames or glass frames?
Picture frame.
Picture frames? You think so? Well, let's see.
So we want to know how many large frames and how many small frames.
That
So
sounds
look
like
how
the
we're gonna
unknown.
set it up.
So I'm going to say large frames and small frames. And we want to know how many she bought. Rather than writing quantity, I could just say number bought. Does that make sense? Number bought. We don't know how many she bought, so what are we going to write there in that column? X and Y, so we'll let X be the large, Y be the small. Now, if you wrote small frames and large frames, you're still going to get use X for small and Y for large. That's fine. You're still going to get the same answer. Let's go back to the problem. Okay, so she bought some large frames and some small frames. Hey, they gave us the large frames cost $14 each. I don't think that's a total. That's just the cost per item, right? That's just the cost per frame.
So, cost per frame.
So the large frames cost $14 and the small frames cost $7.
Is this sort of setting up like the other problem? Well, yeah. But now we need to draw those equal signs.
Mm-hmm. Let me ask you, what are we going to be totaling? We're going to put the totals over here, or we're going to put them at the bottom? Go back to the problem.
At the bottom.
At the bottom. I generally, some people will put, when they make their tables, they may make them so that X and Y are like that, in which case the totals are going over to the right. Maybe I should start doing that, because then the equations would fall out horizontally rather than vertically. But it's just my habit. I always put the totals at the bottom. So look back at the problem. Okay. She bought 17 frames for $161. So what's the total of this column here?
First column. Is he going to put a 7 or 160?
17.
17 or 160?
17. The total number of frames this person bought was 17. Now if you add up the dollar amount, this column is the dollar amount, add up that dollar amount, and it is, what was it? 161.
And where did you get the 17? Was that on there?
That was on there. That you got to keep going back. She bought 17 frames.
Okay.
She bought 17 frames for $161. Well, if we take the number of large frames plus the number of small frames, that has to equal, right? And then she bought, let's say she bought 2 large frames. How much money did she spend on those large frames total? 28. So it's the price per, the cost per frame times the number of frames. 14 times X is the money she spent buying all of those large frames. So we have 14X. You all understand what that's representing? That's the money she spent on the large frames. Cost per frame times the number of frames. Okay, how much money did she spend on the small frames? 7. Cost per frame times the number of frames. 14X is all the money she spent on the large frames. 7Y is all the money she spent on the small frames. If you add that money together, you better get
161.
Okay.
Multiply the top one by -1.
I don't think a -1 will work, because you need to, first of all, what are you going to try to get rid of? Do you want to eliminate the X's or the Y's? The Y? So, I agree. We have a 7 here. We can change that +1 to a -7. Remember, you want the same number, just in opposite signs. So I'll multiply up here by -7. So we'll have a -7X, a -7X. What else? Equals 17 times 7. Is that -119? Yes.
That would be plus 49.
We don't change that second equation. We just write it down. 14x plus 7y equals 161. And remember, you could have used substitution right off. You could have solved for one of the x's and y's and substituted into the second equation. But my preferred method is elimination. And then I substitute to find the second variable. Adding the two equations together, what are we going to get for the x's? Negative 7x plus 14x. I agree with 7x. What happens to the y's? Okay. Equals negative 119 plus 161. I agree with 42.
We should have mentioned this earlier. Would it make sense for our answers to be a decimal number or fractions? Can you buy 3.5 large picture frames?
You should try really hard to think.
Yeah. Could you make 2.5 free throws?
No.
You should expect whole numbers as your answer here. Right?
Not negative. No, I mean, we can say not just integers, because an integer can be negative. You should have negatives. You're right, Tony. We should be expecting whole numbers here. And what are we going to get as the whole number for x? Divide by 7 to give us x equals 6. So that's saying this lady bought 6 large picture frames.
Now you can figure out why just by thinking
don't-
without doing any algebra.
How many small frames did she buy? She got a total of 17. 11. So what number do you add 6 to? What number plus 6 gives 17? You'll get 11. I'll still show the substitution. Once again, I would substitute into the equation as the smaller coefficients. So x plus y equals 17. And we're substituting the 6 here. So we have 6 plus y equals 17. Subtract the 6, and sure enough, that's how you got y equals 11. Any questions there?
So she bought 6 big frames, 11 small. 6 large and 11 small. Any question? Flipping that, look at 15 and 16. Are we wrong when we say they sort of set up the same way? No. Now 17. Yeah.
Well, you should be able to summarize the information with the table, okay? So for these, and they're all just two variables. So, although you could apply the same method to systems with 3 variables, we do a lot of that in Math 1324. We have linear programming with 4 variables, and you still apply the same technique of summarizing with the
Suppose you
table.
bought large frames, medium frames, small frames. Okay? Then you'd have 3 variables, X, Y, and Z.
And I would use, and at that point I'd use Kramer's rule. A 3x3 determinant, use just 3x3 determinants to get them, but so we know what to do if we had 3 variables.
But they don't. Just 2.
The cost to attend a movie is $8 for adults, while children are admitted for $5. If a movie was attended by 60 people who paid a total of $351, how many adults and how many children attended the movie?
So you start it up as adult child, X, Y, and
Okay.
age 5.
Okay, so the
Oh, yeah.
unknowns, we don't know.
Right?
The unknowns, the thing we don't know how many adult tickets were sold and how many children tickets. Those are the unknowns. So the numbers sold, the number of tickets sold, I'll label that X and Y. And go back to the problem again. Okay, so the adult tickets cost $8. I'm going to write cost per ticket. Cost per ticket. So the adult tickets cost $8, and the children's tickets cost how much? 5. Let's switch back. They have to give us some totals somewhere. The movie was attended by 60 people. Where's that 60 going to go on the table?
X plus Y equals 60.
Okay, so totaling up the number of adult tickets and the number of children tickets, that better be 60. They sold 60 tickets. 60 people attended the movie. 351, is that it? Yep, that's the total. The total amount of money. If you total up the money they made, that's $351. The first, what equation results from this column here? X plus Y. Okay. The second one. Okay, so you're taking the cost per ticket times the number of tickets. That's all the money that the theater made from the adult tickets. So 8X, keep going.
Plus 5Y.
Okay. Cost per ticket times the number of children tickets. This is all the money. 8X is all the money that they made from the adult tickets. 5Y is all the money they made from the children's tickets. When you add those two together, it better give us... Okay. Okay. You see, you could eliminate the X there by multiplying by what?
-5.
Now, if you want to eliminate X, you multiply by -8. But multiply by the smaller number. 5's the smaller number, get the smaller numbers. So I agree, multiply by -5.
I forgot the calculator today. And then you just bring over your 8X and 5Y
Okay,
without changing, right?
Right.
so the first equation becomes -5X. Is that, I don't think that green's very visible. And -5X, what else? -5Y equals -30. Did y'all hear what Kristen?
300.
-300. Did y'all hear what Kristen
You
said?
said it right. You heard it wrong.
-5X minus 5Y equals -300. Yes, she said -300, right? And y'all said, what am I going to do with this one? Okay, just recopy. Oh, my blue pen is... Oh, let's try. Throw it away. Oh, wait a minute. So we add the two equations together. What happens with the x's? -5x plus 8x, that gives me 3x.
Cancel lines.
Okay, that's why we've eliminated the y's. That's why they call this thing elimination.
Equals 51.
-300 plus 351, I agree with 51. Divide by 3 to get 17. So 17 adult tickets were sold. They sold 17 adult tickets. 17 adult tickets.
So you can
Okay, remember the number of tickets sold has to equal what? The total number has to equal 60. So what do you add to 17 to give you 60?
I just said 17 plus y equals 60. Don't care more than that.
Oh, okay. So you're not going to think it through. You're just going to do the algebra.
Okay. So you then said, plug in the 17 for x. So we have 17 plus y equals 60. Subtract 17 to give us y equals, and I agree with 43. I heard someone over here say 43 right off. So.
That's right.
Mm-hmm.
Just continue right through it. Okay, a total of 60. So 17 adults means there must be 60 minus 17 or 43 children tickets. So.
I want to skip these problems. These were mine.
Any questions there?
I skip.
You
Oh,
skip
because
them.
I was not good at these at all. These were my, what do you
But
call
they
them?
used to trick you
17.
Yeah.
really bad. This
These
is
are my sacrificial
the way they
questions.
teach it.
17 and 43. Is that right? Okay. Oh, wow.
Here it says to use Gaussian elimination or Gauss-Jordan elimination. Ignore that. We didn't see
That's the
that.
stuff with the ones and zeros that we just barely glanced at. So
Well,
not
we're going to
doing-
solve it using another
We're just
method.
going to use plain elimination.
Elimination here.
Just use elimination.
Just use elimination. Ignore the Gaussian and Gauss-Jordan. Mike works a total of 56 hours per week at his two jobs. He makes $6 per hour at job A and $7 per hour at job
We are
B.
sure ending
We're
this on
ending this on a downbeat note. If his total pay for 1 week is $354 before taxes, then how many hours does he work at each job? Okay.
He needs a new job.
Well, he has two of them, so
He needs 2 new jobs.
So,
either one. new
okay,
job or-
so the unknowns, how many hours does he work at job A, and how many hours does he work at job B?
set it up.
So I'm going to say job A, here's job A, there's job B. And what we don't know is how many hours does he work at job A and how many hours at job B. So I'll say,
X and Y.
I'm going to say number of hours.
Some people might just say hours.
Yeah. Some people might do that. And I'll say X and Y. We could use little a and little b if we wanted to, but I always just prefer X and Y.
And then underneath
Let's
it,
go back. Let's see.
Oh, so you already know the total for that one?
Yeah, the total
Yeah,
hours.
56.
so he works.
Fifth sentence part word.
He worked X hours at job A and Y hours at job B. They tell us he works a total of 56 hours.
Okay, so go ahead now.
And then they also told us something about each job. Didn't they tell us okay, I'll just use that word, wage. Job A, he's paid how much per hour? $6. Job B,
$7.
$7, yeah. Sometimes it's not that easy, though. If we total up all the money he makes, how much? $354. So we have two variables. We have.
Very young person.
Okay, I agree.
Kids probably shouldn't be working 56 hours a week, in my opinion. But that's just. And then it runs to.
Oh no, I don't know what I was doing. Well, I'll just do it down here. What's the second equation?
6x plus 7y.
Okay, so the pay per hour times the number of hours, that's all the money he made at job A, plus How much money did he make at job B? 7 times equals 354. Okay, so good. We're finally eliminating X. It seems like everything we did, we were eliminating Y. Let's eliminate X. That number 6 is smaller. You can multiply by -7, and you'll still get the same answer at the end.
But you'll wind up with a negative X, and no one likes that.
That's right. So Tony's right. I wrote too big. I wrote it here in the middle. So we're going to have to just go over to the here. Distributing the -6, we're going to get -6x. What else will I have? Minus 6y, I agree, equals -336. That's 50 times 6 is 300. 6 times 6, I agree with your -336. The second one, we just recopy. Oh, this is working out nicely.
Are we going to get a fraction as the answer?
Well, in this case, I guess we
could.
You could work half an
1.5
hour.
hours.
Yeah, you could, but I don't think so. Let's see if we're going to get a fraction. Could we get a negative number for X or Y?
X equals 18.
Okay, so adding the X's together, they've eliminated. Negative 6y plus 7y. I think that's a y equals 18. I agree. So
No, I could do it.
realize the X's are the things that have been eliminated. Negative 6y plus 7y gives me 1y. Negative 336 plus 54, that's plus 354, that's 354 minus 336 gives me a positive 18. So he works 18 hours at job B. How many hours did he work at job A? 38. So 56 minus 18, I agree with 38. But I bet you some people want to just plug in. They don't want to think about it. They just want to do the algebra. So go back to the original.
That's everyone's first choice, to do the algebra. What do you mean, Tim?
Okay.
I think that's usually the last choice.
So we then plug in the 18 for y. So we have x plus 18 equals 56. Subtract 18. And that gives us x equals 38. So this person worked 18 hours at job B and 38 hours at job A.
Eight, 18. So job A is 38, and job B is 18.
You know where they put those low numbers
Why?
to make you stay in college?
Oh, is
I
that
guess
it?
you're right. Yeah, it's sort of
Any questions there? Okay, let's stop